In this video, we're going to cover the concept of pressure. Pressure is defined as the perpendicular force per unit area, and it is measured in pascals. The formula for pressure is force over area, and so pressure always is in pascals. Force is going to be measured in newtons, and area is going to be measured in meters squared. So one thing this tells us is that pascals are the same as a newton per meter squared. One common illustration in the real world would be the snowshoe. So what the snowshoe does is it takes the surface area and it makes it larger. And so when you increase the surface area, you decrease the pressure. And so one common thing you would be doing in terms of figuring out how to reduce pressure, you would either decrease the force or you could increase the surface area. This question is asking us to determine which object below is exerting larger pressure on the ground. So we're going to do some calculations here and figure out which one is greater. So one key thing is that when we're talking about pressure, the only surface area that we're concerned about is the surface area that's in contact with the surface. So for the cube, we're looking for the surface area at the bottom here, and then for the cylinder, we're looking for this surface area in contact with the ground. So first, let's calculate the force on the ground. Well, the force is going to be the weight of this object. So it's going to be mg. So that's going to be 4 times 9.8, which gives us a force of 39.2 newtons. Next, we want to calculate the surface area. So we do 2.5 meters squared, and that gives us 6.25 meters squared. And so the pressure is going to be 39.2 over 6.25, which equals 6.272 pascals. So for the cylinder, since it has the same mass, we don't have to recalculate the force. We know the force is going to be 39.2 newtons. The area, however, is going to be different because it's a circle. So we do pi times the radius, which is half of this value here, 1.25 squared. And that gives us an area of 4.908. And so even before I do the calculation, I can already tell that the cylinder is going to have a larger pressure because it has a lower surface area. But we'll just calculate it anyways, just to be sure. But it's going to be 39.2 over 4.908, which gives me a pressure of 7.99 pascals. So due to the lower surface area, we would say that the cylinder is exerting a greater pressure. Okay, now we have a metal cylinder of radius 3 centimeters. See that centimeters there, I'm going to note that. And mass 3.8 kg, falls straight down and impacts soft ground with a speed of 14 meters per second. It comes to rest after traveling 12 centimeters into the ground. Determine the average pressure exerted on the ground. So this is a multi-step problem here. There's a few things we need to figure out. So if I think to the end, I need to find the average pressure. And I know that pressure is force per unit area. And I have the radius of this cylinder here. It's 3 centimeters. So I know I can find the area. Problem is, how am I going to find the force? So how am I going to find the force that this object is exerting as it's traveling down? Well, the clue is that it goes from 14 meters per second to becoming at rest. So from that information, we could calculate the average acceleration, and then we could use the acceleration to find the average force, and then use the average force to find the average pressure. So first, we'll start by finding the acceleration. So the object travels a distance of 12 centimeters. And so I'm going to write that as S, and I'm going to say that's 2.12 meters. Its initial velocity is 14. Its final velocity is 0. And the acceleration, that's what I'm after. So I go back to my kinematics equations, and I look up one that fits all these values here. And it's going to be the equation v squared equals u squared plus 2as, with v being 0, u being 14 squared plus 2a times 0.12. So a is going to be negative 14 squared over 2 times 0.12. And I'm going to plug that in my calculator, and I get an acceleration of negative 816 meters per second squared. So that's a super high acceleration. But thinking of that, it's a metal cylinder. It's falling into the ground, comes to rest only after 12 centimeters. So it's going to have to change its velocity pretty rapidly. Now, what else do I need? I need the area of this cylinder. So the area is going to be equal to pi times radius. And the radius I'm going to have to write in meters. So 0.3 squared. So the area of this object is 0.002827. So a very small surface area. Okay, so now I'm going to use acceleration to figure out the force of the object on the ground. So the negative 816, that's the ground is causing an acceleration of negative 816. So the ground is exerting this force, but I want to know how much force is exerting back. Well, because of Newton's third law, I know it's going to be equal and opposite. So I know that the force on the ground is going to be 3.8 times 816 meters per second squared. So that gives me 3,101 newtons. So the pressure on the ground is going to be 3,101 newtons divided by 0.002827, which gives me a pressure of 1.1 times 10 to the 6 pascals. So it's a rather large pressure being exerted by this object.
In this question, we have a uniform solid cylinder placed in a vacuum on a horizontal surface and exerts a pressure of 4.5 kilopascals. The height of the cylinder is 0.3 meters. What is the density of the material of the cylinder? So it might appear right away we don't quite have enough information to figure this out, so I'm going to show you how to get through this. One thing I want to note is it mentions to us that we're in a vacuum in this question, just because we should ignore any sort of like buoyancy forces or anything like that. So looking at this question, it might not be so obvious where to go. So what I'm going to do and what I recommend you do in these types of scenarios, let's write out some formulas of things that we know. So first of all, we know that density is rho equals mass over volume. And that's ultimately what I'm looking for. And we also know that pressure is the force per unit area. And if I think about this carefully, this object is in a vacuum, so the only force acting is downwards gravitational force. So the pressure is being created by that. So the pressure is going to be equal to mass times gravity over A. And we know that the pressure is 4,500 pascals. So I have sort of a formula here. Now the one thing that I need to connect is that this is actually a cylinder. And the volume of a cylinder is the area of the base times the height. So if you look at this formula here, I can replace this mass over area times height. And I think maybe you should start seeing the connection here. Density times height is equal to mass over area. And 4,500 over G is equal to mass times area as well. And so now I can equate this with this, and I can use that to calculate the density. So I can write rho H is equal to 4,500 over G. And so that means the density is 4,500 over G, H. And H I was given in the question, and G is a physical constant. And so when I plug this in my calculator, I get a density of 1,530 kilograms per meter cubed. So that's the final density of this substance.